Hi, everyone. Let's take a look at number 26 on page 420. A rectangular solid measuring 3 by 4 by 5 is placed on a coordinate axis as shown in the diagram at the left. Part A, determine the coordinates of points C and F. Step 1, your goal is to find the point C. Point C. And again, if you think about this, you have to go on the positive direction on the x-axis 3 times, 1, 2, 3. And you have to go in the positive direction on the y-axis 0 times, and on the z-axis 5 times. And you know this because there's a point D, which is basically 0, 0, 5, which means you go 1, 2, 3, 4, 5. So this means point C must be 3, 0, and 5. Let's write this down. 3, 0, and 5. Now, likewise, trying to find point F. Again, you can press pause in the video. When you press play again, I'll be here. Welcome back. To find the point F, again, this is point F. This means first, on the x-axis, you move exactly 0 times. On the y-axis, you're going to move in the positive direction 4 times, 1, 2, 3, and 4. And for the z-axis, you move exactly 0 times. So again, point F is going to be 0, 4, 0. Again, let's write this down, 0, 4, 0, just like that. Part B, determine the vector CF. Again, by definition, if you want to think about any vector in general, it's always the final minus the initial. So in this case, to find vector CF, you're taking OF minus OC. And since you're given these vectors from part A, again, O is the starting point, 0, 0, 0, also known as the origin. So vector OF is going to be 0, 4, 0. And vector OC is going to be 3, 0, 5. So now, vector CF equals to 0 minus 3, that's going to be negative 3. 4 minus 0, that's going to be 4. And 0 minus 5 is going to be negative 5. Part C, determine the angle between the vectors CF and OP. To find the angle between two vectors, you can apply the dot product. So cosine theta equals to vectors CF dotted to vector OP divided by the magnitudes of vector CF times the magnitude of vector OP. And again, if you go back to the diagram, CF is going to be right there. OP is going to be right there. So you can kind of translate them, which means it's going to look, roughly speaking, something like that. This is going to be vector OP, and this is going to be vector CF. And your goal is to find the angle between them. Now again, this diagram is not drawn to scale, so sometimes the angle is going to be acute, sometimes the angle is going to be obtuse, and we'll get to that in a moment. So in this case, again, from part B, we found the vector CF. Again, from part B, vector CF equals to negative 3, 4, negative 5. Now, from the given, if you think about vector OP, back to the diagram, that's going to be, again, the point P is going to be, you move on the x-axis 3 times. On the y-axis, you're going to move exactly 4 times, 1, 2, 3, 4. On the z-axis, you're going to move up 5 times, 1, 2, 3, 4, 5. So really, the point P is going to be 3, 4, 5, which means vector OP is going to be 3, 4, 5. Let's go back to here. 3, 4, 5, divided by the magnitude of vector CF is going to be negative 3 square plus 4 square plus negative 5 square, and the magnitude of vector OP is going to be 3 square plus 4 square plus 5 square. Now, if you want to work this out, cosine theta equals to negative 3 times 3 is going to be negative 9. 4 times 4, that's going to be 16. Negative 5 times 5 is going to be negative 25. If you have a calculator, you can take it out, turn it on, press clear, or you can use mental math. So negative 3 squared, that's going to be 9. 4 squared is going to be 16. Negative 5 squared is going to be 25. When you add them up, that's going to be the square root of 50. Likewise, same idea, right? This is going to be the same thing because 3 squared plus 4 squared plus 5 squared is going to be 50, just like that. Now, cosine theta equals to, again, if you take negative 9 plus 16 minus 25, it's going to be negative 18. If you look at the denominator, the square root of 50 times itself is going to be 50. Make sure your calculator is in degree mode. Take the inverse cosine of negative 18 divided by 50, and this is going to be approximately 111.1 degrees. I hope this makes sense.